All right, how's it going, everybody? My name is Jacob Crombach, and this is my midterm analysis. So what I took a look at first for that t-test, my hypothesis was that there is actually no statistically significant difference between the defensive ends from the NFL Combine from the years 2005 and 1999 in their vertical leap height. So the skewness and kurtosis between the two groups was not skewed at all. If it were skewed, I was dealing with the entire population, so no adjustments were to be made. So going through the t-test, looking at that F statistic, we're looking at a equal data set, and then from that equal variance, the t-test, according to the t-test, that there is no significant difference between the defensive ends from the 2005 and the 1999 vertical leap heights. And then the p-value, according to the t-test, also shows that there is a significant difference between the defensive ends from 2005 and 1999. Therefore, we must reject the null hypothesis, and the effect size is calculated from the effect size of the difference between the two groups using Cohen's d of a 0.63, which has a moderate effect. Next, we have our correlation analysis. Again, with the correlation between weight and vertical leap is actually a negative 0.54. And according to the significance table, this is actually statistically significant at the 0.01 level. Therefore, we must reject the hypothesis. And again, the effect size according to Cohen is would be a large effect because the correlation is greater than negative 0.5. And then graphically, we have it here showing that trend line. And then with the regression analysis, I hypothesized that the height and the weight can be used in order to predict vertical leap. Skewness and kurtosis, again, they were not skewed. And then the initial regression, height was not a contributing factor for someone's vertical leap. And then second regression, weight can be a predictive factor for the vertical leap up to possibly 18% accuracy. So looking at the graph, we can see that our R-squared value at 0.1838 between the actual and the predicted vertical leap. And that actual equation for the regression analysis came out to y equals 57.08449 plus the athlete's weight times negative 0.08954. And next up, we are actually looking at our ANOVA analysis. So again, the skewness kurtosis was not skewed at all. And I actually looked at a two-way ANOVA. And that ANOVA actually suggests that there is actually not a statistically significant difference between the two groups. And then looking at the effect sizes of the ANOVA, looking at height, we actually had an effect size of 0.29, which has a small effect. Weight having 0.08 with no effect, and then vertical leap at 0.6 having a moderate effect. And then taking a look at the summary for the t-test, from 2005 to 1999, the defensive ends in 2005 actually had a higher jump height than those of the 1999 combine class. And then the correlation, the less weight, or the less that you weigh, you can actually jump higher, or the higher that you can jump. And then regression, an athlete's weight can actually play a part in the individual's vertical leap or jump. And then the ANOVA had no statistically significant difference and only came to have one moderate effect size. Thanks.